Hello everyone, welcome to the third web series. My name is Gaganpreet Singh Hundal and I am a PhD candidate in the Department of Computer and Information Technology and also working as a graduate research assistant for Purdue Digital Agriculture Wind Project. I will be presenting today on the topic sensors, the possibilities are endless. So to start with, I will highlight the basic definition of sensors. Sensors are the devices that respond to external stimulus that can be thermal, electrical, optical, mechanical, or acoustic, and then they generate an output signal that is in the form of a measurable quantity of interest. The output signal generated can be an analog signal or a digital signal. The analog signals are modulated to the digital signals using analog digital converter. Sensors are just like a spinal cord in the human body. To make an analogy, the spinal cord responds to the external stimulus from the surrounding environment, and then they send the signal to our brain, and brain acts as an analog digital converter that modulates that signal in the form of a tangible expression or emotion. So why we are discussing sensors today? Sensors have a wide range of applications in the field of agriculture, and as the topic suggests, the possibilities are endless. The different combination of sensors are used to develop the control system. The different sensors such as temperature, humidity, precipitation, wind speed, light, and CO2 sensors can be used to predict the plant diseases. It can be used for smart water applications, for remote sensing, for mechanical identifying the mechanical crop damages, for microclimatic monitoring, and if we add accelerometer sensors that can be used for identifying and the excessive forces that can damage the crops during the crop transportation and harvesting operations. Now, the possibilities are endless with the sensors, and these are some of the application areas that I will talk about in much detail in the upcoming slides. Now, as I already highlighted, the temperature, humidity, precipitation, wind speed, and light and CO2 sensors have a wide variety of applications, and combination of these sensors can be used to develop different type of control systems at the user end. The first and the important one is the predicting the plant diseases. Now, for predicting the plant diseases, soil health, water quality, and crop temperature are some of the important factors. The soil humidity and temperature sensors can determine the soil health because the moisture content in the soil can vary time by time, and for this we can use the soil humidity sensors. Also, for determining the temperature of the soil and the crop temperature, we have a temperature sensors. We can use combination of temperature, humidity, and precipitation sensors also to determine the water quality and also for smart irrigation systems. The other application of using the combination of these sensors are in the livestock monitoring. Now, if we know the microclimatic condition inside the barns where the livestock is kept, then these conditions, especially the temperature, humidity, relative humidity, and the wind speed, it can determine the health of the livestock in context of the metabolic activity and also the temperature of the feed. Now, the metabolic activity inside the livestock can impact further the feed consumption and the yield rates. So, therefore, these sensors are critical, and the data generated from these sensors can be used to develop the control applications for the livestock monitoring. The other important application can be the temperature, humidity, and the combination of light and CO2 sensors can be integrated inside the grain storage and grain storage facilities to highlight the temperature and the relative humidity, because these factors can impact the the crop, and excessive temperature and relative humidities can basically be very harmful for the crop storage. Also, the temperature and the humidity sensors can be installed inside the grain dryers, and that can determine the inlet and the outlet temperature of air inside the grain dryers. And we can monitor if the temperature is excessive or the humidity is excessive. That can be alerted in the form of the applications, and farmers can be able to monitor these factors in order to prevent the damage to the crop. So these are some of the applications. Now, this slide highlights the various classification of sensors based upon the sensing stimulus and the sensing technologies, and along with that, the applications in the agriculture field. Some of the applications I already highlighted here. The important thing is how we classify these sensors, and also some of the non-contact sensing technologies that are becoming pretty much popular these days. As I told, the non-contact sensors can be used for the applications to measure the temperature and relative humidity of air. And some of the applications are to use them at the grain storage facilities, also in the dairy farms for monitoring the livestock, and also they can be used to measure the leaf temperature. The other important application is the greenhouse monitoring, because light and temperature is important factor in greenhouse monitoring. So the non-contact sensors can be used for this application. The other important sensor type is the accelerometer sensors that can be used in the farm machinery, and the data generated from these highlighting the forces during the crop transportation and harvesting operations. Now, the excessive forces, mechanical forces during these operations can damage the crops. So the accelerometer sensors have a good application in this regard, and the livestock tracking can also be done using accelerometer sensors. And I will talk about these in the coming slides. So the various classification of sensors, and I will talk about the temperature, relative humidity, precipitation, wind speed, accelerometer, light and CO2 sensors in much detail. So to start with, I will talk about the temperature sensors now. Temperature sensors are classified in four categories: thermocouple, thermosistors, resistor temperature sensors, and optical infrared non-contact type thermal sensors. So the first two categories are thermocouple and thermosistors. Thermocouples can be used for high temperature, wide range of temperatures, and they are also low cost and highly sensitive. The other type of sensors are thermosistors that are made up of semiconductor materials, and you can see here they are from the calibration curve that they are highly sensitive. And in semiconductor materials, what happens is, as the temperature of this material decreases, the resistance increases, and vice versa. So the basic principle of the operation of thermosistor sensors is that as their resistance will change with the decrease in temperature, and the current will vary inside that. That is an output parameter. The other type of sensors are resistance temperature detectors and infrared optical fiber non-contact type thermometers. Now, the non-contact type thermometers are can highly be used and in the applications of measuring the temperature of air where there should be no contact. For example, they can be used in the temperature, measuring the temperature of the leaves. They can also be used in the storage facilities, the grain storage facilities, the grain dryers, automobiles, and also the storage facilities, the livestock storage facilities, the livestock farms. Also, the non-contact type thermometers are very accurate and they are corrosion resistant. This slide highlights the different categories of thermal sensors based upon, the comparison is based upon sensitivity, temperature ranges, accuracy, cost, stability, and the various kind of applications they have. Some of the applications I have already talked about, but the important one here is the optical non-contact type thermocouples, temperature sensors that can be used for thermal remote sensing applications and monitoring the leaf temperature. The other important ones can be the thermocouples that have a wide range of temperature measurement, and for high temperature measurements, they can be used. Now I will talk about the humidity sensors. The humidity sensors are critical to measure soil moisture, conductivity, relative humidity of air, and grain storage for predicting soil health, plant diseases, and crop storage conditions. There are 4 types of humidity sensors: capacitive, resistive, thermoconductive, and optical. Now, these are the calibration curves of different kind of sensors, humidity sensors. The calibration curves also highlight the idle calibrations here and the relationship between the input variable and the output, that is the measurable parameter that we are interested to measure in. Now, capacitive humidity sensors can work up to higher ranges of temperatures, and also they are very stable, resistant to condensation and chemical vapors. Thermal conductive sensors find their application to measure the absolute humidity, and they have a better resolution as compared to capacitive and resistive sensors. The non-contact type humidity sensors measure the relative humidity, and they are very sensitive and stable, and also low cost option and accurate also. So as we compare the 3 types, optical relative humidity sensors are pretty much find their applications in the area of measuring temperature inside the storage facilities, grain storage facilities, also inside the livestock barns, dairy farms, and they can also be mounted upon different type of farm machinery. But the capacitive sensors, on the other hand, can be used for weather stations, food processing facilities, and they work at a very high range of temperatures and have a good sensitivity, higher accuracy, and also low cost option. So the next type of sensors are the precipitation sensors, which are also critical for determining the amount of precipitation and its impact on crop and soil health. The first one is the tipping bucket sensors, which are low cost and reliable. However, their accuracy decreases with high rainfall. On the other hand, we have the impact type precipitation sensors that works under the higher heavy rainfalls and requires less maintenance. And the application of different type of precipitation sensors, the amount of precipitation is a critical factor. So for example, for heavy rainfalls, the area, the geographical locations having heavy rainfalls, the optical and impact sensors can be deployed there that can work under higher accuracy. And on the other hand, the Doppler radar sensors that have higher resolution, and therefore they can measure the small amount of precipitations in the form of fog, mist, and dew. So the geographical regions that experiences low amount of precipitations, the Doppler radar precipitation sensors can have a good application there. The next type of sensors is the wind speed sensors. Wind speed is a critical factor as excess winds can damage crops, harmful for livestock health and storage facilities. The four different type of wind sensors are windmill, hot wire anemometer, ultrasonic, and optical, which are non-contact type. And the hot wire anemometers can measure the very low air velocities with accuracy. And the principle is very simple, is that as the air velocity increases and it passes through the hot wires, the temperature varies. The basic principle of heat transfer and convection. The other types are the ultrasonic and optical, that are non-contact type wind sensors. They are very highly accurate, and the ultrasonic non-contact type wind sensors are suitable for turbulent and high-speed winds. So the geographic regions experiencing high winds, there the ultrasonic sensors have a good application. The next type of sensors are the accelerometer or the force sensors. Accelerometer sensors are critical for determining the hazardous mechanical forces during harvesting, grain drying, and crop transportation operations. They can be deployed on the farm machinery, and I will give an example in the upcoming slide. Also, they can be used for livestock tracking and monitoring the activities of the livestock, which can further impact the feed consumption. So the first type are the piezoelectric accelerometer force sensors. Piezoelectric sensors are basically quartz crystals, and when the force is applied to them, they generate current, which is an output signal. Piezoelectric sensors are self-powered and they are suitable for low power applications. On the other hand, the piezoresistive sensors can operate at higher temperatures, but their shortfall is they require power and are unsuitable for low power and battery operated systems. On the other hand, we have the capacitive and the optical, that are non-contact type sensors, and they are very highly accurate and can measure wide ranges of accelerations. Now, the different type of accelerometer sensors are classified here based upon the range of measurement of forces, accuracy, sensitivity, and response. The response is critical for the accelerometer sensors because if the response is low, then the latency of the data sent from the sensors is low. In this case, the latency is important because the excessive forces generated during the time of the operations, harvesting operations, or during the crop transportation can impact the crops, they can damage the crops. So the critical alerts sent at the right time and with very high response rate can be an important factor to alert farmers that the excessive forces are generated along with the excessive vibrations and that they can damage the machinery as well as the crops. So now I will talk about the farm application of accelerometer force sensors. And you can see here, the first application is the deployment of accelerometer sensors on the farm machinery such as tractors. And these are the positions where the accelerometer sensors can be deployed. Now the first one is at the front of the chassis of the tractor on the tire, and on the overhaul. Now, why the accelerometer sensors are important at these locations? Because these are the locations that can impact the field operations. The forces generated from these positions can impact the field operations and the crops. The overhaul, where the harvester is deployed, there, if the excessive forces are there, they can damage the crops, the tires, and also the front position. This front position can help to determine the actual acceleration of the tractor. And they can also help for the farm navigation and locating the position of the tractor. The other application is of the accelerometer sensors is in the livestock tracking and monitoring. The accelerometer sensors deployed at these locations in the livestock, they can help to find data about the activity of the livestock, and the activity data can help us to basically relate it to the feed consumption, because higher the activity, higher will be the feed consumption because of high metabolism of the livestock. And also the other application can be tracking and localization of the livestock, where the livestock is. Now, these factors can contribute towards the livestock health. The other important type of sensors are the light sensors. Light sensors are basically photoresistors, semiconductor devices that use light energy to generate an electric current through them. The resistance decreases with the increase in light flux. That is the basic principle behind working of light-dependent resistors. Now, the other one are the gas sensors, the CO2 sensors. Why we use light and CO2 sensors is because the basic principle of photosynthesis, from which the plant generate energy, depends upon the light and the CO2 concentration and intensity. Now, higher the light and the CO2 concentration in the air, higher will be the photosynthesis rate to up to some point. That is the maximum rate of photosynthesis. And at this point, the rate of photosynthesis is maximum with the appropriate amount of light and CO2 in the air. Now, we use the light and CO2 sensors for different type of applications. The first one, the basic one, is for greenhouse monitoring. As we know that light and carbon dioxide are the critical parameters that impact the photosynthesis rate. And by measuring these parameters, we can figure out the various plant diseases that can occur if there is not appropriate amount of light and carbon dioxide for photosynthesis. So the other application, an important application, is monitoring the light and the CO2 condition inside the grain storage facilities, because low light intensities or higher CO2 concentrations can impact the crops inside the storage facilities, and they can damage those. The other application is in the livestock monitoring. And also the light and the CO2 concentrations and intensity, they can impact the temperature and also the humidity, relative humidity. Now, we know that CO2, excessive amount of CO2 in the air can, through the phenomena of greenhouse, can increase the temperature, and they can monitor the microclimatic conditions. So the impact of the light and CO2 on the microclimatic conditions is the important factor, and they can impact further the health of the livestock. Their metabolical activities might vary, and that it can impact the feed, and also it can impact on the yields. Now, there are various sensing technologies that are non-contact type, and I have talked about them in some way in the previous slides. The acoustic, optical, laser, and ultrasonic, and the research is going on in this area, that is of the future sensing technologies. And because they are non-contact type, they can have a wide range of applications. Some of them I've already talked about. The important here are the laser and the ultrasonic sensors that have a very high range of measurement accuracy, and sensitivity. And the research is going on how to make them low-cost sensors so that they can be deployed inside the various facilities and can be used for a wide variety of applications for the farms. Now, we talked about different kind of sensors. So what we do after we deploy all the sensors and what we do with the data and how the data travels and how it is aggregated. So this is the IoT Internet of Things framework for digital agriculture applications. And we talked about the sensors today. Sensors act as a perception layer. Now, the data from different combination of sensors can be aggregated and it can be transferred to cloud storages. The transfer layer is the communication layer, which uses wide variety of technologies such as LoRa, TWS, Bluetooth, GPRS, and other communication technologies depending upon the application. And once the data is transferred from this communication layer, it goes to the data processing layer, the cloud services, through which we aggregate the data and we process the data, we filter the data, and then we basically try to develop some of the application layers for alerting the farmers that these application layers act as a user interface layers. And from these application layers, different type of monitoring systems, which we talked about, can be developed. So this is a kind of a framework. Now, this slide relates to the previous slide. Different kind of cloud-based analytics and simulations can be developed to figure out the implications of different decisions on the farm. So the data generated from different kind of sensors can be aggregated at the cloud platform, where we can put some parameters and simulate the environment, and we can figure out, okay, if we put this much amount of water based upon the soil health, the temperature and the moisture content in the soil, then what can happen to the crop? We can simulate that environment. Or if we put this much fertilizer on the soil and the soil has this much amount of pH, the soil has this much amount of moisture, then what that amount will have an impact on the plant growth. And we can predict also the plant diseases by simulating the different factors. So the cloud-based analytics and farm simulations is becoming a reality today. And therefore, the possibilities of sensors in this regard is endless. So these are my references. Thank you very much for listening, and I'm open for questions.